Okay, so let's start. So as I told you, my name is Muhammad Mahmoud. This is the office. This is my office is here. I sent you an email again because I'm using the system for the first time. I sent you an email yesterday. I'm not sure if you have received it. Okay, good. So yesterday I uploaded the chapter 1 syllabus and this slides I call it chapter 0, which is like syllabus. This is my email here. Okay. As you know, we are going to meet every Sunday, Tuesday, Thursday in this building, in this room from 8 a.m. to 8:50. Okay. So all the materials related to this course, I'm going to post them on Blackboard. Also, I'm recording, as you see here, I'm recording all lectures. I'm going to record them, and then I'm going to post them on YouTube channel, this channel. So you have to keep this playlist or this link. You have to keep it somewhere. So I'm going to record all the lecture just in case if you miss something in the lecture and you want to go back to it. Okay, so I'm recording right now. Hopefully it's working. I guess it's working. Okay. Also, these are my office hours in this room. Okay. And for sure, at any time, if you need any help, you have my email here. You can email me. Okay. The way I teach any courses, okay, I just want to teach it in the best way possible. And the best way here means the best way for a student, not for me, okay? So I really strongly welcome if there is any feedback, how I can improve my teaching so that you can understand information better or make it easier. I'm happy for that for sure. So, you know, Network 1 is a prerequisite for this course. In chapter 1, I'm going to make a very quick revision on Network 1 just to make like refreshment. Then I'm going to start with the topics here. So these are the topics I'm going to teach in Network 2. First, introduction. Okay, and this introduction is taken from chapter 1 and chapter 2 in the textbook. And this is the textbook here. Yes, Frozen. So this is a textbook we're going to use in this course. On addition of this book, I'm going to use some online resources. So chapter 2, I'm going to talk about data and signals, digital transmission, analog transmission. So as you know from Network 1, in network we have layers, the 7 layers. I'm gonna go through them again, quickly make a quick review. So actually here, the first three chapters here actually are gonna be in physical layer, in the first layer, okay, related to physical layer. And these 2 chapters after that, data link control and multi-axis control, these 2 chapters are gonna be related to layer 2. Okay, data link layer. And then this one here is going to be related to layer 3. So yeah, so the focus of this course is to focus, this course is going to focus on the first 3 layers. Okay. So these are the number of chapters in the textbook. Okay. For sure, if we have time, I'm going to cover security and cryptography. So anyway, this is the objective of this course. For sure, to understand what in details what happens in the first 3 layers, and this is a course learning outcome. So I'm going to leave it for you to read it. This is a textbook. Yeah. So now I'm going to talk about grading. Okay, I know you care too much about grading, so I'm going to talk about it. So for grading, we're going to have some homework, some assignments. Okay, this will be 10% of the final grade. It's going to be around 2 assignments. We're going to have a project. This one will be 20%. We're going to have quizzes, 15%. I will try to make 4 quizzes. We are going to take the best 3 out of 4. Final exam is going to be 25%. Attendance is going to be 10%. Is that clear? You have any questions? You agree or disagree, or is that good? Yes.
What do you mean by attendance? Like participation in class?
No, attendance. Attend the class. You got what I'm saying? For sure, I encourage you to participate, to ask a question and to answer my questions, but attendance, you attend the class. So if you attend all the classes, you are going to take 10%.
Oh, we have to attend all
to get 10%.
of them. One lecture, how much?
It's going to be 1 over the number of lectures times 10%. You got what I'm saying?
It's like a bonus. No, actually.
Yeah, you need to attend to understand the course. You got what I'm saying? But I'm for sure I am somehow flexible. So what I can do is that, for example, if you miss 5 classes, for example, okay, so still you can get the 10%. Okay. So one more thing, for sure, very important. You have to attend on time here. I know this course is this section is too early, 8 o'clock, but you have to attend on time. If you come late, please don't make disruption for us. Okay. 8 o'clock means 8 o'clock. That's what I know in the United States. 8 o'clock means 8 o'clock. 8:01 is not 8 o'clock. Okay, so 8 o'clock means 8 o'clock. Please don't come late. Okay. Anyway, in class, for sure, you have to respect the instructor. You have to respect your colleagues. You should not. You have to make sure your phone is off. Don't make disruption. Okay. You can use any, for sure, you can use any computers or other devices to take some notes. Okay. I'm not sure for the student who joined us late. Yeah, you still have 2 minutes to take the attendance. Okay. So the code you have to use is 6608. Yeah, attendance policy. You know, here in Qatar University, if you absent more than 25% of the class, you will get FB. You know that. This is a policy. It's not my policy. It's a university policy. Okay. And anyway, you need to attend to understand, okay, the course. This is the purpose of learning or education. You need to understand the course, okay? For sure, academic integrity is important everywhere. So cheating is not allowed. So if you copy from someone, this is cheating for sure. If it happens, for sure, I have to take action for that. I wish it doesn't happen, but you know this academic integrity. So you have, if you need any help, I can help you, but you didn't need to copy from someone else. Okay. For sure, you have to do homework by yourself. I have some expectation here. Number 1, you need to attend lectures. We don't have labs for sure here. Try to understand it. Class participation is important. At participation, not attendance. So if you have any question, just raise your hand and ask me. I'm totally fine with that. You should understand the slides, lecture, and also assignment. I'm expecting that you turn in organized and neat assignments and project. I want you to focus here in the class, and you can take some notes. What I'm gonna do, I'm gonna before I teach any chapter, I'm gonna post the slides online. The best way you can print slides and you can take notes, or you can take online notes. Okay, so it's if you need, for sure. If you need any help, I always tell my students, this is my career, this is my job, is to help you. So if you need any help, just let me know. I will do my best to help you because this is my job. Okay. You have to study the material as soon as possible after it is presented, because this is a problem in learning or in education. If you wait, so now if I teach you today 10 slides, okay? If you study today, it's only 10 slides, okay? But if you wait to next time, the 10 are going to be 20. If you wait 1 week, it's going to be 30. If you wait a couple of weeks, so now it's going to be more, you are going to make it more. This is one thing. The other thing is, this is how learning is. I think in most of places is how it is. In chapter 2, I'm going to use chapter 1. So we do chapter 1, I build on chapter 1. Chapter 3, they're going to build in 1 and 2. So if you don't understand one chapter, you're going to create a gap. You're going to make it difficult to understand these chapters. You got what I'm saying? I just want to also tell you some students can read the slides before I teach them. Just read. I'm not saying study. I'm just, you can go through the slides before. That's maybe it's a good way to understand the course as well. Not all quizzes assignment have the same weight, so you have to pay attention to this one. Late assignment are not, for sure, I don't encourage to submit late assignments, so try to submit on time. I think that's all what I have. Do you have any questions? Okay. Okay, but this is the last time. Next time I'm not gonna take.
So will also be attendance the first 5 minutes?
Yeah. I'm gonna try to take the attendance again. Yeah. So you have 5 minutes now. It's 4084. Okay. One more thing I did, guys. I posted the description of the project online. So as you see here, as I told you, the project is going to be 20% of the total grade. This project, there are 3 phases in this project. In the first phase, this is actually 2023. I'm sorry for this mistake, 23, okay? So in the first, in this project, what you have to do in this project is, you should have a problem and you have to do programming, okay? This programming can be either, you can use as, yes, sure. 4084. Yeah. So what you have to do here in this project, mainly you have to do programming, okay? You have to program a network problem somehow. And what you have to do here is, for example, here I give you a list of things you can do here. For example, yeah, you can evaluate the performance of a routing protocol. So I give you a list of topics here, and you actually can you can select a different topic from these ones. In this programming, you can use a simulator. You need simulator like NS2, NS3, OPNet. Okay, you know, in we like simulations because it's very cheap. You don't need to do like hardware implementation. And now simulations are really very efficient, so very accurate now. So somehow you can get good estimation to the outcome if you implement the network. So we have NS2, NS3. Okay, we're gonna provide you with a tutorial about how can you use them. You can select. You can do. Real implementation if you want, but for example, socket, you know, socket programming, so you can have 2 computers and you can send data between the 2 computers. Anyway, so here I'm putting a lot of details here in this slide. So here in this is the first phase. In the first phase, you need to like to make a proposal about the idea. You are gonna make a project in this idea. So I'm giving here, so every project can have between 4 or 5 students. And also I give you a lot of details. It's the title of the project, student name, abstract, tell me what you want to do. Okay, for example, you want to measure the quality of service and whatever. Okay, guys. Any questions? Okay, so let's start with chapter 1. Okay. As I told you, chapter 1 is going to be a revision to network 1. Maybe you know some of this knowledge, maybe you don't know some of them, so I will do my best to explain it very well. So let's start here. You have very good slides, very detailed slides. Okay, so in the first part here, I'm asking you, what is communication network? What's network? What communication network is? That's a question, okay? Very simple. So we have here something, we call it a network, okay? Something, we call it a network. And we have a bunch of computers. These computers are connected to the network, okay? And what the network has to do is it has to transfer data from one computer to another. That's it. So everything I'm going to teach in this course, everything you learn it in network one is about how can you transfer data from one computer to another. That's what the network has to do. You got what I'm saying? For example, computer A want to talk to computer B. So you have to send the data. The network has to deliver this data to network B, to computer B. This is what network is, okay? Inside the network, you can find a lot of things, for sure. It's not as easy as I explained. There are a lot of things has to be done inside the network, okay? So network means we want to transfer data between devices, but inside the network, you can find what we call links. You can find what switches and other things I'm going to explain in this course, okay? Switches, routers, okay? When I say end host or end computer, end, the word end here, end, means it's end device, end, okay? It's connected to the network, okay? Because there are a lot of devices inside the network itself. So also we have protocols, we have application, and a lot of things. Why we need a network? I shouldn't ask in our era at this time. I shouldn't ask why we need a network, because day and night we use networks, right? For sure, we need network to share data for communication, to share file access for chat, emails, and other things for sure. Okay. Another question: why we need networking? Because what is the alternative? What is the alternative if we don't have a network? The alternative is I have to connect every computer with point-to-point communication, which for sure it's impossible. Okay, it's impossible to connect every computer to another computer point-to-point. Okay, or it's impossible to do that. That's why we need networking here. Okay. And as you see here, inside the network, we have a bunch of routers, switches, whatever, so that to connect the data from one computer, to deliver data from one computer to another. In the second section here, I'm going to explain some definition and concept about networks, okay? So the first thing I want to explain is the word protocol, because all the time in networks, we use protocols. Every layer has protocols. So what do you mean by protocol? What it means, okay? In our life, we use some protocols. For example, here I want to know what is the time. So I'm going to ask this guy, hello, he's going to reply to me, hello, what is the time? The time is 2 o'clock. You got what I'm saying? So if I need to get some information from you, so there is an agreement, or I have to do it in a certain way. That's what we call a protocol. Same thing for devices here. If I wanna see, if I wanna download a page, okay. So if I wanna, for example, to go to a certain website and see this website, so number one, I have to use a certain protocol. So protocol means I have to send a message. If you wanna do that, there are steps. Number one, you have to send a message. This message is called to connection request. And this message has a certain format. We agree on this format. For example, you have to put here 10111, okay? So that the other side, when I see the 1110, I understand you are requesting a connection. Okay, this is the meaning of it. So this is the number one. And then you have to wait until I reply back with this message. This is the meaning of protocol. So protocol means we are going to agree on the format of the message. We're going to agree what is the first message, and then you have to wait until I reply back to you, and then you have to do this. I have to do that until we finish, okay, what we are doing, okay? One more thing, maybe for the same layer, we can have several different protocols that can do the same thing. For example, in the transport layer, we have UDP and we have TCP. both of them are doing the same thing. Okay. However, for sure, as I'm going to explain now, the performance requirement may be different. So what I want to say, for every layer, you may have more than one protocol. They are doing the same thing, but every protocol there are performance difference between them. Okay. The next thing I want to talk about communication link. So when I say communication link, what do you mean by communication link? Okay. So as you see here, for example, here I'm connecting a computer to a router using a link. Okay. So actually, any communication link should have a medium. It should have error bit rate. It should have link rate. So what this means? Number one, medium. So what do you mean by medium? Medium, how you are going to send this signal between this computer or between this computer and this router, okay? You know, currently you can use a copper wire. You can use a copper wire to do that. You can use the air, okay? If you do wireless transmission, this is a medium. And also, what else I can use? Fiber optics for sure, okay? So this is a medium usually we use, fiber optics and wireless communication, and also it can be a copper, okay? You know, which one is the best regarding bit error rate? Fiber optics for sure. The bit error rate is very low in fiber optics. You know why? I'm gonna tell you why. For sure, if you send the signal in the air, there are a lot of problems, okay? Number one, the quality of the channel itself, it changes based on the temperature, based on if it is humid or not, okay? Also, there may be interference, okay? For example, if you use any device, the lamp or any device you are using, it's going to generate electromagnetic. So this is going to make a noise, interference. You get what I'm saying? Same thing for wire. When you have a wire, okay, this wire, when there is some electromagnetic field around the wire, this electromagnetic field is going to create noise here. So it's going to make the signal noisy. Okay. The good thing about optical fiber, it's light. It is a light. You know, optical fiber. It's just you have here fiber, okay, and then you have light. So this light is immune against any electromagnetic field around it. You got to see? That's why you know most of communication between cities and this is how we connect the whole world. You know, there are big cables, fiber optics cable. They put it under the oceans, okay? Because we can. Why fiber optics? Because again, the bandwidth is huge. You can transmit too much amount of data. Okay. Anyway, so that's what I'm saying. When I see a link, so I want you to understand when I say if I want to connect a computer to a router or a computer to another computer, there should be a link. So this link can have a medium. This medium can be guided or unguided. Okay, guided, like for example, if you have a copper wire, if you have fiber optics, unguided if it is just in the air, free air. Okay, so like radio waves. Also, every link has a bit error rate. What do you mean by bit error rate? Bit error rate means, okay, so I'm gonna transmit 0. Okay, if everything is perfect, every time I transmit a bit, I'm gonna receive the same bit on the other side if it is perfect. But it's not perfect, okay? So you can transmit 0, the other side is going to receive it 1, okay? Or the opposite, you transmit 1, you are going to get 0 here. That's error, okay? So this is natural. So it's normal to have such errors. So every cable should have a bit error rate. Or what is the probability of getting for example, if the bit error rate is 1%, that means every time you transmit 100 bits, you are going to get 1 bit wrong. Okay, so something normal. For sure, the lower the bit error rate is, the better for sure, okay? The other thing is here is the link rate. Rate here means how many bits you can transmit per second. How many bits speed. Can I transmit 1 billion bits per second? There is a limit. It's not open, there is a limit, okay? For example, when I see here, it's 1.5 megabit per second, that means this is the limit here. I cannot transmit more than 1.5 megabit per second. That's what I mean. For sure, the higher the link rate, for sure, it's better. Anyway, So, any questions here? Okay. Now, I'm going to talk about, as I told you, we have hosts. When I say the word host or in the system, okay, so I mean the computers connected, because for any network, as you see here, we have, for any network, we have devices here, and we have end nodes are connected here. So I want to make sure you understand when I say end node, what do you mean by end node? You can tell from the English name end, because it's at the end here, okay? So any computer that transmit data or receive data, I'm going to call it end node. We have some nodes inside here. The word node, when I say the word node, I can use the word node for a computer or for any router inside here. Okay? The other thing also, I'm not sure if you know it or not, but we are going to explain in details in chapter, in one of the chapters, because this is done in layer number 3. There is something we call it routing and route. So what do you mean by routing? What do you mean by route? Okay, very simple. So the idea is that, let me go back here. Okay, assume, for example, this computer A want to communicate to computer B. Okay, guys. So there are different routes to do this. So, for example, I can send the data to this router. This router can transmit this way and then can transmit this way. This is one route to do it. Okay. There may be another route. This route here. There may be another route. It can go this way, right? So there are different routes. Same thing when you drive. When you drive, I can go this way, or that way, and then this is the meaning of routing. Okay. And we have a protocol to do that. Okay. And who's responsible to do that? Layer number 3, right? The network layer. So the network layer should decide which route it has to go. Okay. And so, and maybe one route is better than others. It's exactly the same thing when you return home. When you go to home, maybe you know this street is busy. So you are going to try to avoid it, and you can take another street. Same thing. If there is some congestion here, okay, and so maybe, or there is a long delay here, maybe I'm going to prefer another route. So they may not be exactly the same thing. All the routes are not the same. Okay, maybe some of them are better than others. So that's what I'm saying here. So you should understand what is the meaning of routing. Routing means if you send a data, I want to deliver it to the destination. So which route it can take? Okay, so that's routing. And the route, for example, this can be one route, or this can be another route. So the data can go through node A, node B, or it can go through C, E, F. So this is a route. Okay. Any questions? Okay. Anyway, I think, yeah, hopefully this chapter is easy. So also we have here some definitions about transmission modes. So for example, here we have simplex transmission mode. So simplex, you may know. So here the transmission is, direction of the transmission is one way, as you see here. Okay. Let me. The second one is called half duplex. So this one is bidirectional. So here only the communication is only this way, okay? But here the communication here bidirectional. So it can be this way and also can be this way, but not at the same time. So either you transmit or you receive, not at the same time. Full duplex is actually you can transmit and receive at the same time, okay? 8 o'clock means 8 o'clock. 80.1, 801 is not 8 o'clock. So the next thing here we have is, any questions here? Yeah, just simple definitions, okay? Next thing here is, I just want to make sure you are familiar with ban, lane, main, when. So sometimes we classify the network based on the size, okay? So for example, if the network is too small, we call it personal area network or a ban. For example, if you have a smartphone connected to a headphone, wireless, for example, this can be a very small network. If the network is bigger, okay, for example, the network is in a building or something like that, we call it a lane. or for sure, if it's cover a whole city, we call it a man, or we can call it a wan. Okay. So based on the size, just want to make sure you are familiar with these terms. Okay. The next thing, and I think it's very important, I'm not sure if you are familiar or not with this one or not, but I'm going to spend some time talking about it because you need it in the project. It's important. Okay. So quality of service, what it means. Like any service in life, there should be a way to measure the quality of this. How good is the service? Okay. For example, when I teach this course, this is a service. Okay, there should be a way to measure how good is my teaching. That's one way to do it. By the end of the course, I think you do some evaluation to the instructor, right? So this is one metric to evaluate the service. Okay, same thing here in network, we have a service. So what is the service in the network? Delivering data. So as I told you before, this is a service. It's just to deliver the data from one computer to another. So how can we evaluate the quality of this service? There are some metrics we can measure. So I'm gonna go through them. Hopefully you are familiar with these ones. So what the first metric here, we call it reliability. There may be other metrics, but I'm gonna focus now on three main metrics. The first metric is reliability. The second one, there may be different names, by the way, but they mean the same thing. So sometimes they call it reliability. Sometimes you call it accuracy, whatever. So maybe it has some different names. Transmission speed, throughput, into delay. Okay. So this, I'm going to focus only on these three metrics to how good I want to measure how good is the service. Okay. One more thing here I want to tell you. So this service, this metrics may depend on several things. May depend on the transmission media. For example, if you're using wireless, you should expect the reliability is not good. Why? Because there are a lot of errors in case of wireless. If you use fiber optics, you should expect the transmission, the reliability is going to be too high, because probability of error is very small. You got what I'm saying? So it depends on the media. It depends on the capacity of the devices. What do you mean by capacity? I mean, you know, every router is a computer. Every router is a computer. It has CPU, it has memory, okay, and so on. So it depends on how big is the memory. It depends on how fast are these devices and so on. It depends on the protocols itself. Very important. That means I may have one protocol and someone can come up with a better protocol, and this better protocol can have better quality of service. Okay, so let me go to define them exactly. What do you mean by these metrics? Okay, so let's start with the first one. Very simple. I'm going to make it very simple. So for the first one here, as I told you, in any network you have here, this is a computer A and this is computer B. Okay, so when I transmit here, for example, I want to transmit 100 packets or 100 messages. So what do you think? If I can get all of them delivered, I'm happy. This is the best service I can provide to you. Is that okay? I'm going to send 100, I'm going to get 100. Okay, this is 100% reliability. Is that okay? But this is not the case. It's not the case. What happens, sometimes I'm going to send 100, but I'm going to get here, for example, 80 or 90, for example. Or the other ones, I lost them. Why? For sure, there are reasons for that. Okay, I'm gonna go through them quickly, but this is the reliability. Very simple. How many packets I'm gonna transmit, how many I'm gonna receive. This is the reliability. For sure, if I can receive all of them, this is a best case for sure, but this is not the reality. Okay. So very important question. So why, when I transmit a message, this message got lost here? It was not delivered. What is the reason of it? There are different reasons. I'm going to give you at least now two reasons out of it, okay? The first reason is, as I told you, maybe the channel itself. Channel, they call it a channel impairment. For example, here, when when you send the data from one router to router or computer to computer, whatever it is, the channel itself here, when you transmit, for example, a bit, error happens, okay? And the packet is not delivered, okay? Because this is something normal. That's what it's normal. When don't think every time I transmit a bit, I'm gonna receive the bit correctly. It's not true. You got what I'm saying? So this is something normal. I transmitted the message, but there was some error. Because there is error, so this one is gonna drop it. It's not gonna relay. Okay, for sure. As I'm gonna explain in this course, there are some ways to fix this problem. Fix the problem. Okay, if I received a message and this message was wrong, there was some mistakes in this message. So as I'm gonna teach in this course, maybe it's a very easy way. Okay, I can ask this computer, please retransmit. This is an easy way to solve it, retransmit, okay? Anyway, but this can be one of the reasons. There is another reason, a very important reason, we call it congestion. Congestion. Okay, you can tell even from the English name, congestion. So what this means, what congestion here means, okay? It means, look how it works. This is how our life is. This is how it works. Look here, guys. We have here a router, okay? This router is going to receive data from different computers, okay, this way, okay? Should I get a permission from the router before I transmit? Should I ask the router, do you have time to serve me? Can I transmit data to you? No, we don't do that. If you want to transmit, just go ahead and transmit. This is how the internet is. If you want to transmit, just go ahead and transmit. What happens if this computer are going to transmit too much data are coming? Remember, this router has a capacity. It has a CPU, certain computation, it has certain memory, it has a capacity. Okay. What if the arrival rate, the rate arrival here is bigger than the output rate or transmission rate? What I can do? Because when I receive a packet, I have to do some processing and then I have to transmit. This takes time. What if I receive too many packets and I'm not able, okay, to deliver all of them? It's like, for example, okay, I'm going to give you a very nice example. For example, you are a router, okay? Every course, like a computer, okay? If all the instructors of all courses give you too many assignments, tomorrow you have to deliver 3 assignments from me, 3 assignments from, can you do all of them? No, you have a capacity. You cannot do all of them, right? What can you do? You have to drop some of them. Okay, so this course, I'm going to do one out of 10. This one, I'm going to do 2 out of 10, okay? Because you have exactly the same thing, okay? So what happens, that's what we call congestion, okay? So congestion means because there is no agreement in the very beginning about you don't take permission. If you're not transmit, just go ahead and transmit. Because of that, it may happen that this router is going to receive too much information or too many data in a very short period of time. So what happens actually, I'm not gonna start to dropping right away, because when you drop a packet, that's not a good thing for sure. Okay, it's not a good thing for sure because this packet has already consumed resources to arrive to this router. So what happens here, this router should have a memory. So once I receive a packet here, so actually I'm gonna store it in memory. Okay, hopefully I can, after I finish what I'm processing now, I can get it from the queue. We call it a queue. So I'm gonna save it in the queue. But again, keep in mind, queue is a memory, megabytes. So I don't have infinite queue, so limited. So once the queue is full, okay, I don't have any other option. I have to drop. Okay, that's what we call congestion. Okay, guys, you understand what I mean by congestion? And usually this congestion is handled. It's not good for anybody, because congestion, again, we're going to lose resources. You transmit, and maybe several routers are gonna transmit the packet, and then the packet is going to be dropped in the middle. So it's not good for anybody. So usually we're not going to teach how can we do it in this course. I'm not sure if you took it before or not, but this congestion problem usually it is handled by the transport layer. Okay, so there are certain mechanism to avoid this problem. It's not good for anybody because we're just consuming resources without doing the work. You put effort without finishing the assignment. You got what I'm saying? So anyways, this is the main point here. So again, what I was explaining, why, one reason why when you transmit a packet, this packet is not going to be delivered. This is one reason for it, okay? And also, the same thing is related to another issue I'm going to explain right now, is about the delay. This is the second metric here, delay. So what do you mean by delay? What I mean by delay, when I transmit a packet from here, is not going to be transmitted in 0 seconds. For sure, it's going to take some time. There is some time. Okay? Why? This is just electrons. Electrons are moving. This is a light. It should be very straight. It shouldn't take any time. No, the answer is no. Because there are a lot of factors. One of the factors is you. Maybe when you transmit a packet, the router is already busy, so I'm going to keep it in the queue. So it's going to take some time for me until I get it out of the queue. You got what I'm saying? So anyway, so again, I was talking about the quality of the service. We can measure it using reliability. Reliability is very simple. Means if you transmit 100 packets, how many you are going to get at the end? Okay. And the reliability, the reason of the reliability is actually the bit error rate. Okay. Sometimes we call it packet delivery ratio. Okay. So again, as I told you, there are different names for the same thing. Okay. Yeah, here I'm giving the reasons because of the why we may lose some packets, because of the congestion, because of the channel impairment, and so on. The third, I'm going to jump to the third one because I already mentioned it. The third metric here is the delay. As I told you, how much time is going to take from you. You got what I'm saying? The delay. When I transmit a packet here, okay, at time t, I'm going to receive it at time t plus delta. So how big is delta? For sure, I would be happy if it is 0. But again, because it's not possible to make it a 0, so there should be some delay. Okay. So why there is a delay? I already mentioned one reason for the delay, the queue. If there is a congestion, when the packet arrives to the router is not going to send it right away. And already the router has a queue. You have to wait. Because I'm saying this is one reason. Another reason is, even when the router, we call it nodal processing delay, when the router receives a packet, okay, it has to do processing to this packet. I have to check, I have to look, I have to see the routing table, as I'm going to explain later for sure. I'm going to look, I have to see the address. Yeah, this packet, it's going to go to this destination. So I'm going to look in the routing table. I'm going to see, yeah, if this one has to go to this place, so I have to output it from this output, or this output, or this output, or this output. You got what I'm saying? Processing. So there should be some processing. It takes time. Okay. Propagation delay. Maybe this is a very little delay, but still it's a delay. Propagation. Propagation means when you transmit a signal, the signal has to travel from one place. It has to travel. The signal itself. It's going to take some time. Okay. Transmission delay. What do you mean by the transmission delay? As I told you before, the cable itself. The cable itself is introducing a kind of delay because you cannot transmit more than, for example, 5 packets per second. This is what is a link rate. So the link rate is introducing some kind of a delay because there is a limit on how much information you can transmit in a second. Anyway, the second metric here, the third one here, is actually the transmission speed or throughput. Okay. Throughput means how many bits per second I can get. How many bits per second I can get. Okay. Transmission speed. Okay. So, and actually, again, sometimes we call it throughput, sometimes we call it transmission speed, sometimes we call it data rate, bandwidth, or whatever. So there are different names here. And by the way, it can measure, there is a little difference. It depends on how you define it. I know maybe people define it in different ways, but all of them means the same thing, speed. Okay. There is a very little difference between bandwidth and throughput. Okay. So bandwidth means it means how much data transmitted per second. So and the throughput means how much bits delivered per second. Okay, it's a little bit different. So what I'm saying here, I can transmit here, for example, 30 packets per second. This is, I call it bandwidth, okay? So only I care about how much data I transmitted. I can see how much data I received here, because you know it's not perfect. We may drop some packets here. So we can call it, we can call this one bandwidth, we can call it this one throughput. How, for example, if you transmit 30 packets or whatever per second, and I'm gonna get 25 per second. So actually, yeah, so always the throughput here is actually lower than the bandwidth here, okay? Because is the best case, if you transmit 30, I'm gonna get 30. You get what I'm saying? So anyway, yeah, bandwidth is the transmitted, the throughput is delivered. You get what I'm saying? I'm not sure, maybe other people it's just a definition. Some people may deliver it in the other way or whatever, but the way I want to define it here, we can, in general, you can measure it from here or you can measure it from here. Yes, I want to define it this way. Okay. For sure. So throughput can be like effective data. This is the effective. Okay, effective. So anyway, so in conclusion, guys, network like it's a service. In service, you should have some kind of metrics to measure the quality of this service. Okay, and here I'm gonna use 3 metrics. Maybe someone else is gonna use different metrics, but we are gonna use three metrics. The metrics we are gonna I explained right now is reliability or packet delivery rate, transmission speed or throughput, and also delay. Okay, how much delay? Okay. The last thing I want to mention is, so that I finish this one, just give me 1 second. Okay. The last thing I want to explain here. Okay, you told us we have 3 metrics. That's okay. So do I need to do well in the 3 metrics? So I need to get the best throughput, the best delay, the best accuracy. The answer is it depends on the application. Some application is going to tell you, I don't care about the delay. I don't care about the delay. I care about it in order to provide a good service. I care about reliability. For example, here for example, email or file transfer protocol in email. Do you care if your email is delayed 1 second or half a second? I don't care. But I do care if my email is not delivered. So here, I don't care about data rate. I don't care about packet loss has to be close to 0. So I don't allow this one. In something like voice over IP, if you talk to someone, right? So I have a restriction on the delay, because if I do care about the delay, yes, because if the delay is not short, the voice will be broken. So I'm not going to hear well. You know what I'm saying? So anyway, the conclusion is we have 3 surfaces. We have 3 metrics, and actually every application can care about some of these metric. Can put some, as you see here, I can put some restriction based on the, to provide good application or good service for the application, good quality for the application. Okay, guys. Okay. See you next time. Please come on time, please. Okay. So I'm gonna post this lecture. I'm gonna post it online. Okay. Huh? What's that? It was 8 o'clock. Yeah.